Okay, now we're going to learn about properties of logs and exponents. Well, properties of exponents you've been working with since probably Algebra 1 or before. And remember, logs and exponents are inverse operations of each other. And if you look up at the parent graph, graphically you can see that their graphs are inverses of each other. So let's go ahead and talk about the first property that I'm going to talk about is the product rule. Well, remember in the laws of exponents, when you multiply powers of the same base, notice the base is both of the bases there are x. When you multiply powers of the same base, you add the exponents. Well, look what happens when you have logarithms. So what we have is log of base b of x plus log of base b of y, and what happens is it's equal to log of base b. The x and the y get multiplied and it becomes one logarithm. And then look what happens over here. When you multiply powers, the exponents get added. When you add logs of the same base, the values get multiplied. So they're very closely related, but kind of inverse processes. Okay, so let's go to the quotient rule. In laws of exponents, when you divide powers of the same base, you subtract the exponents. For logarithms, the quotient rule is when you subtract logs with the same base, you divide the values. For the power rule in the laws of exponents, when you raise a power to a power, you multiply the exponents. And in logs, when a value is raised, look at the exponent comes out in front. This exponent right here, this n, comes out in front, and then it multiplies by the log of the value. All right, so let's look at a couple examples. All right, so we've got the product rule. So we have log of base 2 of 5 plus log of base 2, 11. And look at what happens. When you add logs of the same base, you multiply the values and rewrite it as a log. So log of base 2, and it becomes 5 times 11, which is 55. There you go. All right, so let's move that out of the way. The quotient rule. When you subtract logs of the same base, the values get divided. So the same base there is 5. So then you would rewrite that as log. And it's always the first value divide the second. So log of base 5, 8 over 3 in parentheses. All right, and then the power rule. Log of base 3, x to the 5th. And look what happens when you look at the power rule. Whatever that exponent is, it gets brought down in front and then it gets multiplied. So that would be 5 times the log of base 3 of x. So if you the exponent rules and the log rules, if you can keep them straight, they're pretty easy. So let's go ahead and do the expansion. So now these two things are multiplied. What did they start off being? Well, remember that when we added logs of the same base, the values got multiplied. So we're going to do the reverse. So that becomes log of base 3 of a plus log of base 3 of b. And then if we evaluated that, it would be this. All right, so now we've got a division. Log of base 2 u, subtract log of base 2 b. And notice the order. The u is in the numerator, so that is the one subtracting the log of base 2v. And in the product rule one, so the A comes before the B. And not that it necessarily has to work that way, but that is a good idea to do it that way. All right, one more thing. Notice that's a root, but remember, what have we learned about roots? How can that be rewritten? It can be rewritten as x to what power? The 1/3. So think about the cube root of x as x to the 1/3. And then when you evaluate that, the exponent comes out in front, and then it gets multiplied, just like that. And then we have a value here. So again, that's just the 5 will come out in front, log of base 3 of u. All right, that's it. I think that's all. Yeah, that's it for this video on the properties of logarithms.